So let's talk about these guys here now, and then we'll move on. Um, let's see. Ooh, I'll put this over here, and we'll deal with these after. So we have these two questions over here. And does anybody have an answer for this one, number 3? X is what?
5/4.
X is what?
5/4.
X is 5/4. Anybody get anything else? Anybody got anything different? Nobody got anything different. What do we remove? Look at this side of the equation. What should we remove first?
-3.
Yeah, so the -3 is furthest away from the x, so we'll plus 3 on both sides of the equation. So you notice a plus 3 ends up there. And so the 3's are gone. We'll just have 4x/5 is equal to -2 plus 3. When the signs are different, you find the difference and keep the sign at the larger number. So the difference is 1. And what should we get rid of now? The 5 or the 4?
5.
The 5, yes. We could get rid of the 4. We could just go divide by 4 on both sides, no problem. That is possible. But the safest thing to do is get rid of that denominator first. The 4 is being busy divided by the 5 right now. So let's get rid of the 5. So we multiply by 5 because that 5 is dividing. We have to multiply by 5 on both sides of the equation. So these 5's are gone. So now I'm left with 4x is equal to 1 times 5, which is 5. And now how do I get rid of this 4? Divide by 4 on both sides of the equation. So these 4's are gone, and I end up get x is equal to 5/4. Indeed, very good, Isaiah. You win some team points there. Of course, you guys do have teams. We could have teams, if you want. Somebody else, give me number 4. Anybody have an answer for number 4?
X is equal to -3.
-3. All right. So you have. Anybody have any other answers? And first of all, before I even move on to number 4, does anybody have any questions about number 3? Zara, you understand what we did here with number 3, right?
Yes, sir. That's it.
Lovely. Very good. So we could see here that we need to get rid of this -2 first by adding 2 on both sides of the equation, right? So what we'll end up with, these 2's are gone, so we'll end up with -2x/3 is equal to 0 plus 2 is 2, right? Now we could multiply both sides of the equation by 3 to get rid of this divide by 3. I'll multiply by 3 on this side. So now I'll have minus 2x alone is equal to 2 times 3, which is 6. Now I have to divide by -2 on both sides to get rid of that -2, and I will end up with x is equal to 6 divided by -2, these 2 over here. And these 2 have a purpose, right? The purpose is, yes, you could see that the plus 3 is furthest away from x. Right? Oh, let me just take off the dog. Sorry. Okay. You can see the plus 3 is furthest away from x. Well, is it furthest away from x though? Because you would think that to get rid of that plus 3, I could just minus 3, but no. Because that is not plus 3. That's deceiving you. That plus 3 is busy being divided by 2. Yeah? And so you don't want to touch that plus 3 yet. The easiest thing to do will be to get rid of the 2. So you multiply by 2 on both sides of the equation. That will get rid of the 2. So now we'll just have x plus 3 alone is equal to 4 times 2 is 8. Now we could get rid of this minus 3. You see, it's unimpeded. Yeah, it have nothing butter in it. So we could get minus 3 on both sides, and we get x is equal to 8 minus 3 is 5. And anybody could tell me what x will be for number 6?
1.
1? And
I think, yeah.
no problem. Even if you're wrong, that's fine, And feel free to give wrong answers, Feel free. Wrong does not mean that you're stupid or anything like that. No. Wrong means that you're trying, and you keep trying if you want to succeed, right? So, anybody got anything other than 1?
X will equal 3.
All right. So we have a couple of answers. I like when we have a couple of answers here, right?
I got 0.
You guys, yes, lovely. Anybody get anything else? All right. So watch this one now. And I love that we have all of these different answers, right? And you see the people who got it wrong. It doesn't mean that you are worth less. What it means is that you are learning. So the people who got it wrong, check this out, right? We need to remove the numbers that are furthest away from x first. Remember what I said. Multiplication and division glues numbers together. Addition and subtraction separate numbers. So this minus here means that this 3 is separated from the x, yes? But we have this long divide, the vinculum of the fraction. And that long divide means that this entire x minus 3, that is one numerator being all divided by minus 2. So that means that minus 2 go on and make this entire thing one fraction. So you see how division glues numbers together? Because that x minus 3 was two separate numbers. It's that minus 2 that come and glue them together to make one big fat fraction. Yeah? So, we can't touch anything there. All of that is one number. So the number furthest away from x is minus 1. Sorry, not minus 1, plus 1. So in order to get rid of the plus 1, I'll minus 1 first. Yeah, I had a minus 1 on both sides though. And so now this plus 1 is gone. Now I'll just have the x minus 3 over minus 2 alone is equal to 1 minus 1 is 0 on this side. Now I still can't touch this minus 3 because that minus 3 is being divided by that negative 2. So let me multiply by negative 2 on both sides of the equation. That will get rid of the negative 2 here, and I'll have x minus 3 alone is equal to 0 times negative 2 is 0. And now I have x minus 3 by itself. Now I could tackle this minus 3 by adding 3 to both sides of the equation. And now x will be equal to 0 plus 3 is 3. So x is equal to 3. Excellent job. And excellent job to the people who got it wrong too. That is fine, getting it wrong. The most important thing is you understand where your error was, right? So Kyla, do you understand where you went wrong?
Yes, it's a mix of the operations.
Oh.
Minus 3, not adding.
Oh, so you minus 3 again here.
Yes.
Interesting.
So until after when I did a video working, I realized it.
Right. Okay. And how about you, Sharice? Do you know where you went wrong?
Yes, it was a careless mistake.
Yes, the careless mistakes do happen to the best of us. Even Einstein had to have people proofread his papers because anybody could mistake a little negative. So you had to have people proofreading their papers. And you can't have one person proofreading the paper because they might miss the mistake. You had to have 5 or 6. That is what you call peer-reviewed, right? So today we're going to be talking about something slightly different but pretty much the same. It's the same kind of thing, but today we're talking about something called transposition. Transposition is just a quicker way to do the same thing. So is yeah, Ade, you saying something? No? Okay. All right. So yeah, it's just a quicker way to eliminate numbers. Right? We literally, I just say you just fling it across the equal sign. So we throw numbers across the equal sign and they become their own opposite operation. Right? So what do I mean by that? Well, you know how to solve this. To solve this, we minus 3 on both sides of the equation to get x is equal to 5 minus 3. X is equal to 2, right? But with transposition, all right? In fact, I wouldn't put transposition. I'll put the transpose. All right? Means that I could have x plus 3 is equal to 5. And I could recognize that I want to get rid of this add 3. So I will take it up with my hand and fling it across the equal sign. I go fling it over there. And when I fling it over there, I'll have the x alone on this side is equal to 5. And when I fling and add 3, they become their opposite operation. Right? So when you throw numbers across the equal sign, they become their opposite operation. So an add 3 will become a minus 3. Right? So this is what we call we transpose the 3. We transposed the add 3. That is what we just did. We take the 3, we fling it across the equal sign, it became subtract 3, and x is equal to 2. This is transposition. Right? To be able to literally fling a number across the equal sign. Now what we did essentially was we skipped this step. So if you know how to transpose, means that you will be able to skip a step which will make your working faster. Right? So you could always get your working done quicker if you know how to transpose. Transposing does come with rules though, so you just have to be careful. For example, you can see that I fling this plus 3 across and it became a minus 3, a subtract 3. Why did it become a subtract 3? Did it just magically become a subtract 3? Know the reason why. Why did it become a subtract 3? This is why. Because what we actually did was we actually subtracted 3 from both sides of the equation. That is what we actually did. Right? So transposition is just a quicker way, one step faster, right? If you know how to transpose. So when you transpose, when you throw across and add 3, it becomes a minus 3. This is why. Any questions? Let me hear some donuts for this slide here. So I'm seeing somebody in the chat there. Done it. Thank you, Samaya. Anybody still didn't done it? I see how you done it. Done. All right, lovely. All right, so moving on. So this is just another example, and I'll just give you a couple of examples of transposition, right? So for example, you know here that in order to get rid of the subtract 5, I need to add 5 on both sides of the equation. So that means that I'll have x alone here is equal to 10 plus 5 over here, which means that x is equal to 15. However, if I was to transpose, you could see that I'll have the same problem. X minus 5 is equal to 10. And I could just transpose the minus 5, fling it across. And so I will just have x is equal to 10 plus 5. It will become the opposite operation. It will become the opposite operation. So a subtract 5 will become an add 5. And so x is equal to 15. You can see it's the exact same question. It's pretty much the exact same procedure. It's just that we skip in this step, right? We skip in this step. And so this is just a little faster when it comes to actually figuring it out. So let me hear done it for this one, please. Yeah. You will have a whole bunch of donuts, right? So you can see that when we transpose in, we fling a number across the equal sign, and it'll become its opposite operation. So when we fling an add, it'll become a subtract. When we fling a subtract, it becomes an add. Anybody ever saw Stranger Things? Nobody here ever watched Stranger Things?
Yes.
Yeah. One person watched Stranger Things. Janasha, you never watched Stranger Things?
Yes, I saw it.
So this equal sign here, you could think about it as the gateway. The gateway to the upside down. Yeah. And anything that crossed the gateway, this become upside down, the opposite of what it was. So if you take the minus 5 and you throw it across the gateway into the upside down, it'll become the opposite, the plus 5. Zara, you ever watched Stranger Things?
Yes.
All right. Zara, do you understand this whole transposition business?
Yes.
All right, lovely. It's just an easier way to do the same thing. So you're seeing that when we actually have those questions, right? And so look, we have another example here about transposition. In this example, the first thing I would have to do is minus the 3 from both sides of the equation. So now I will have x over 2 on this side is equal to 5 minus 3 on this side. So therefore, x over 2 is equal to 5 minus 3 is 2. Right? Then I would have to multiply by 2 to get rid of this 2, but I'll have to do that on both sides. And now I'll have x is equal to 2 times 2. X is equal to 4. However, when I am transposing, it could just be done a little bit quicker. X all over 2 plus 3 is equal to 5. I know I have to get rid of this number first. It's the furthest away from x. So I'll fling it across into the upside down. So now I'll have x over 2 is equal to 5, and that'll become a minus 3. Right? So x over 2 is equal to 2. Now I grab this 2. It's a divide by 2. When I fling it across, x is going to be equal to this 2 multiplied by this 2. Yeah? So remember, when you fling it across, they become their opposite operation. It's not about sign, it's about operation. So this was a divide here. When I throw it across, it became a multiply. We get x is equal to 4. If you know how to do transposition well, it'll actually speed up your algebra. Your algebra will get really, really fast. And let me get some donuts for this one, and any questions? So you can see in a question like this, we worked the exact same way where you had to think about, well, what do I get rid of first? The number furthest away from x. And then you just fling it across. Yeah. And then what do I get rid of next? Well, this divide by 2. So then you just fling it across. And it'll become a multiply by 2. Right? And so it's a fun way to think about it. And look, we have, do I have any more? Yes. So that's the end of transposition there. And then we have this example here. So this example here, you know, what I would usually have to do is I would want to get rid of this first. So I would add 2 to both sides of the equation. That would get rid of these 2's, and I would be left with minus 2x is equal to 2 plus 2 on this side. So minus 2x is equal to 4. Then I would have to divide by negative 2 on both sides of the equation. So those negative 2's are gone. So now I will just have x. Therefore, x is equal to 4 divided by negative 2. X is equal to negative 2. On the transpose side, I have negative 2x minus 2 is equal to 2. All I had to do is take up this subtract 2, fling it across. So I'll just have negative 2x alone is equal to 2. And that subtract 2 will become an add 2. Yes? Now, negative 2x is equal to 4. I know I have to get rid of this negative 2, but it's a multiply. So when I throw it across, x is going to be equal to 4 divided by negative 2. Notice the sign did not change. It was a negative on this side. It still remained a negative on this side. Why did it still remain a negative on this side? This is why. Because what you're actually doing is you're actually dividing by negative 2 on both sides. So please be careful. It's not about the sign, it's about what the number is doing. In this case, the sign is a negative, yes, but the number itself is multiplying. So when you throw it across, it will become a divide. And now you get x is equal to negative 2. So you see, just a couple less steps, transposition really helps you out. Just to make things a little faster, let me hear some donuts for this one. Welcome, Naima. Naima, I have your absent, Naima. Welcome. Welcome, Naima. Hi, Naima. Did you miss the last two?
Yes, sir. I keep forgetting.
You keep forgetting. Wow. Well, you missed some dreadfully important classes there. Yeah, you missed some dreadfully important classes there, but I'll have to show you where the videos are, right? Who is home to? Home to. Please put your name so that I can know who you are home to. Could I see home to, please? Whoever is home to. Hello, home to. I don't know who home to is. JQ. Ah, yes. Thank you, JQ. Welcome, JQ. Right. Nice. So we have a summary of transposition here. Note these refer to operations and not signs. These are not signs I'm talking about. These are operations. Always determine what the number is doing. If the number is an add, when you throw it across the equal sign, it'll become a minus. If the number is a minus, when you throw it across the equal sign, it will become an add. If the number is a multiply, you fling it across, it'll become a divide. If it's a divide, you fling it across, it'll become a multiply. So let me just hear some done it. Now transposition may seem easy, but you do have to be careful It is one of those things that makes it easy to make those careless mistakes, yeah? It's easy to make careless mistakes with transposition, but if you master transposition, your algebra will be lightning fast. Anybody still writing here? Because I only got one done it.
Got it.
All right, so here.
Yes, I feel that.
No problem. Sorry about that. Sold. So, I gave you guys these questions to do last time where you had to solve for the unknown. Did anybody actually do them? Show by raise of hands, please.
So at the start, that's when you did show it at the beginning.
All right. So I have 3. Get it started. I have 4. All right, cool, right? Zara, did you do all? Because you didn't have to do all, you know. You could have just had to do some.
Yeah, I did do all.
Wow, well, that's great. That's great, right? And I do have a video where I do correct all, but today I don't know if I will have time to go through all, but let's just go through these 8 at least. All right, these 8 have some decent things to test on. And Zara, apart from these 8, for anybody who did all, if there are any specific ones that you would like me to look at, let me know and we will look at it, right? But for now, we're going to just do these 8, and this is what I'll allow you time in today's class to do. So, for the rest of you all who didn't do nothing, you see the people who raised their hand, I'm not going to be calling them name, eh? The people who didn't raise all their hand, I'm going to be calling all their name, eh? Oh, I see you raise your hand now. I see her raise your hand one time. All right. That's her raising. She raised your hand one time. So here's what. 5 minutes to do these 8 questions. That's pretty much almost. That should be enough time for you, right? So 5 minutes to do these 8 questions, and for anybody who did do them, you have a little bit of a break. And remember, if anybody did all of the questions, please feel free to ask me to do any of the others if you want me to do it now, no problem. Yeah. But for the next 5 minutes, I'm timing you now, so it's 6:51. So 6:56 is when I'll start calling some names, and we'll see. So see if we could just do these 8 here. Now, you know 2 ways of doing it. You know it the normal way where you're minusing, balancing the scale from both sides. And then you also know how to do transposition, to just fling things across. So you can feel free to try transposition if you want some. 5 minutes, well, less than 5 minutes, right? Less than 5 minutes. I went for water. Oh, I do that. Okay. Yes, right. And JQ is great. JQ, did you do all? How much did you do? I'll go back to the dog here. All right, great. Well, Hannah, I mean, if Alia really want me to go through all, I don't mind going through all, you know. I really don't mind. It have other things for us to do, but I don't mind correcting all. Right? You know what? What could happen is I could call 8 names to give me these 8, and then I could just do the rest real quick for anybody who want confirmation of right and wrong and all of that, right?
Yes, sir.
This is the second class of those 10 classes. Those 10 classes will take us into the first week of August. And then maybe the second week of August is when we could start set theory. And then we'll take a break for the second 2 weeks of August. And we'll come back in September with the rest of the curriculum being things like consumer arithmetic and geometry and all of them kind of things. But if we could finish set theory before we take a break, that would be awesome. Yes? Remember, we're doing the entire curriculum from scratch. Samai. And the time is up, but is anybody still working? Or is anybody done it? You was doing the last 2. I have one done it. I have a couple of done it. All right. If we have some done it's going on, then let me see. Let me see. So anybody could tell me what is the answer for V? What is V here? V is 10. All right. Could somebody else tell me what is the answer for Z?
Z is equal to
12. Could anybody here tell me the answer for Y? 5. Could anybody tell me the answer for R? 8. What about Q? 2. What about A?
16.
Thank you very much. What about Y? What about F?
12.
Excellent job. So let's run it through, right? So we see in here, the first one is 3V plus 3 is equal to 33. I am going to use transposition, right? If anyone is getting confused by my transposition, please let me know and I will do it the normal way, right? But first, this plus 3 is furthest away from the x, so I'll fling it across. So now I'll have 3v is equal to 33 minus 3. That plus 3 will become a minus 3. So 3v is equal to 30. And now I'll fling across this 3. It's a multiply by 3. So v is equal to 30. It will become a divide by 3 on this side. So v is equal to 10. Excellent job for the people who got 10. And if I go in too fast, please let me know. If I write in it too fast and you're still writing it down, it's no problem. And whilst you're writing that one, I could do the next one on this side. Right? So the next one is 2z is equal to 24. And I'm going to fling across this 2, and you can see it's a multiply by 2. So z is equal to 24 divided by 2. Z is equal to 12. So I'll close this one now. Anybody still on this one? Three y is equal to 15. I'll fling the 3 across, so y is equal to 15 divided by 3. Y is equal to 5. Easy peasy. Lemon squeezy. We have 2r plus 3 is equal to 19. Well, first I need to get rid of this, so I'll fling that across, and I'll just have 2r alone is equal to 19, and add 3 will become a subtract 3. So now 2r is equal to, what is that, 16, 17, 18, 19, 16. And now I'll fling the 2 across, so r will be 16 divided by 2. It's a multiply by 2 on the side. R is equal to 8. Yeah, man. Again, some real good thing here. Zara, how you doing with them so far?
very good, actually.
Very good. So you're getting them correct.
Yeah.
You're understanding them. Even if you're not getting them correct, that's still good. The most important thing is not right or wrong. It's understanding what you're doing, right? So I have 4 multiply by q. That's how I'm going to say it. Minus 30 is equal to negative 22. I have to throw across the minus 30. Throw that across. So 4 multiply by q is negative 22 plus 30. So 4 multiplied by q is, well, when the signs are different, you find the difference, which is 8. You keep the sign of the larger number, which is the 30. So we're good there, right? And now I throw across the 4. Q is going to be equal to 8 divided by 4. Q is going to be 2. This is a really important one. This one here, super important one. Negative A is equal to negative 16. A good algebra person will be able to watch this and immediately say A is equal to 16. Yeah, somebody who's good at algebra could jump from there to there one time. But why? Because I'm going to take this negative and throw it across. What is that negative? Is it a subtract? No, it's not a subtract because it's not subtracting from nothing. It don't have no other number that it's subtracting from, right? So that negative is actually a multiply. That is negative 1 being multiplied by A. So when I throw across that negative, I actually throw in across negative 1. And it's a negative 1 being multiplied here. So when I throw it across, it'll become divide by negative 1. And so you can see the negatives will cancel. A is 16 divided by 1, which is 16. So this is a really important thing to recognize. To recognize that when you have, like, say, minus x is equal to minus 3, you can immediately say x is equal to 3, right? So that is one example. Another example is if you have minus x, sorry, let me write that a little better. If you have minus x is equal to 3, you could immediately say that x is equal to minus 3 for the same reasons, right? So somebody who is experienced in algebra will actually be able to come to those conclusions without having to go through all of these steps, yeah? Then we have negative 3y minus 2 is equal to negative 8. Well, I'm going to take this negative 2 or the subtract 2 and throw it across. So I have negative 3y is equal to minus 8. This minus 2 thrown across will become a plus 2. So now I have negative 3y is equal to, you know, when the signs are different, you find the difference, which is 6, and you keep the sign of the larger number, right? And so now I'll throw across this negative 3. This negative 3 is a multiply. So when I throw it across, it will become a divide by the same negative 3. And so we can see here that y is equal to 2. I got some really, really great answers from people, man. Excellent. Excellent job, guys. Are they walking? Are they cooking with Ramco? And then this last one, easy peasy. We have f minus 2 is equal to 10. We're just going to throw across this minus 2. F is equal to 10 plus 2. F is equal to 12. So you see, transposition just generally makes life easier, right? Now, I know you guys did all, and I don't know if I have, because it have a couple other things we have to do in this class, so I don't know if I have time to go through all, but I will ask, is there any particular one that anybody would like me to look at? Now, I do have a video in the Google Classroom where I do answer at least most of them. So if you would like to check that out, I'll show you all where that video is. And I do have to organize the Google Classroom a little better. That is something that I have to do. But at least I can show you all where the videos are. Anybody have any questions on this? Any questions at all? All right, moving on. Polynomials. The word polynomial, and this is kind of a new topic, you could say. Poly meaning many, nomial meaning numbers. So polynomial means many numbers. So you could see here that all of these questions, they have an equal sign, but they don't have anything on the other end of the equal sign. So these guys are not equations. These guys are, what do you call it?
Polynomial.
No.
Oh, expression.
Expressions, right? They are not equations, they are expressions, and we can't solve equations. Sorry, we can't solve expressions, but we can simplify them, right? So you could see here, number one, anybody, x plus x is what?
2x.
Yeah, the quicker all your answers, the quicker we get out of here. But you can't have Sarah answering all the time. Yeah, so x plus x is 2x. All right, so one bag of mango plus a next bag of mango is give you 2 bag of mango. Yeah, that's all. And you can see that if I have a bag of mango multiplied by 2, I'll have 2 bag of mango. So 2 times x is 2x. X plus x is 2x. They just operate just like normal numbers. They operate just like normal numbers. So somebody other than Sarah, number 3, 2x minus x is what?
1x.
1x, yeah. 1x, yes, but you don't have to write the 1. The 1 is understood. Yes. And then what about x plus y? What is x plus y?
Nothing.
Well, I wouldn't say nothing. The answer is x plus y.
XY?
Not xy, careful. xy means x multiplied by y. Right? So be careful. So the point is that whilst I could add an x with an x, and I could subtract an x from an x, because x is the same thing, it's the same bag of mango. But over here now, I have a bag of mango plus a bag of orange. So where does get when you add a bag of mango to a bag of orange? Well, you just get a bag of mango plus a bag of orange. You can't add them. You cannot add them. So when you have different unknown numbers, you cannot add or subtract them. They will just stay in this form, right? So we cannot add or subtract different unknown numbers. Okay. Also look at this. This 2 here. The number in front of the unknown is called the coefficient. So when we have a number in front of an unknown, it is called the coefficient. And you can see here that over here it is understood. All right, a coefficient of 1. Oh gosh, man. A coefficient of 1 is understood. In front of understood. In front of every number. You don't have to write the 1. So it have a 1 in front of here and it have a 1 in front of here. In front of every number, a 1 is understood And of course, if it's a negative number, a minus 1 will be understood. Let me hear some donuts for this one. Janasha, you cool so far?
Yes.
Why are the tongue thing in my head when class going on, bro? Anybody still writing? Okay, no problem. Take your time. Let me hear the donuts. I see you still writing there? Right. Anybody still writing? So, what is x minus y?
X minus y.
Very good. Can't really do nothing with that. X minus y. If I say I have a bag of mango and I want to minus a bag of orange from the bag of mango, well, guess what? You're gonna good luck doing that. Yeah. So two different numbers, you can't really do much with it. What if I have x times x?
X squared.
X squared.
Very good. This will be x squared, just like any ordinary number. Just like any ordinary number, right? What if I have x times y?
XY.
This one will be xy, and you could see that that multiplication glues numbers together. So even though it's two separate numbers, multiplication naturally glues numbers together. So you could see that nothing didn't really change. Yeah? This is x times y. This still means x times y. So nothing didn't change. But because multiplication naturally glues numbers together, means that we could write this as one number, right? Also, and we'll talk about this just now, but it's commutative as well, right? So it could be yx. This is also correct, right? But generally, we like to keep it in alphabetical order. So even though yx is correct because multiplication is commutative, we would normally write it as xy. Yeah. Division, on the other hand, is not commutative, but division still glues numbers together. So how could I write x divided by y as a glued together number? X over y. Yeah, it still means the same thing, but I could write it glued together. So you could see now what I mean when I say that multiplication glues numbers together to form one number. Division glues numbers together to form one number, a fraction. But subtraction separates numbers, and over here addition separates numbers. So now you could see it. Let me hear some donuts for this one.
One.
Anybody didn't done it yet? You see, I had no problem singing for all you, so why does have problem singing for me? I don't understand. Anybody still didn't done it? Oops. Right. So we are speaking of the commutative law, and we could see that in the commutative law, addition is commutative. So x plus y is equal to y plus x. Addition is commutative. You could see over here, subtraction is not commutative. So therefore, x minus y will not be equal to y minus x. Yeah, you can't flip that. So for example, if I have 10 minus 5, that could never be equal to 5 minus 10. Right? But I still say that it's unfair. To say that subtraction is not commutative, that is unfair to subtraction. I just feel sorry for subtraction because honestly, these two are not the same question. In this question, the 5 is being subtracted. In this question, the 10 is being subtracted. So they are not the same question. When we look at the associative law, you will see how we could flip things around. Yeah? But just know that subtraction is not commutative, but take a look at this. Multiplication is commutative. So we have x times y is the same as y times x. Yeah? So therefore, xy is the same thing as yx, even though we prefer write it like this. Right? But this is also correct. Yeah, you wouldn't get it wrong if you write it like this, but it's just the person marking your paper will know that you are not a mathematician. Right? Mathematicians will write it like this. Yeah, x divided by y is not, division is not commutative, so that is not the same as y divided by x. Yeah, so if I have 10 divided by 5, that is not the same as 5 divided by 10. They are not equal. So we have the commutative is addition and multiplication, and then subtraction and division are not commutative. Let me hear some Dunnets. Now this is a revision. The commutative law, we did this, we did the associative law, we did all of that. All of that stuff that we did in arithmetic, commutative law, associative law, distributive law, all of them things, we are going to do them over in algebra. And you're going to see that they are all the same thing. Letters are not different from numbers. They are numbers in maths. It have no letters in maths. It only have numbers. So that is the commutative law. This is the all-important associative law. So take a look at this, right? Subtraction is not commutative. So x minus y is not the same as my y minus x. However, the associative law does allow us to flip it. What is the associative law, you may ask, in case you don't remember it when we did arithmetic? The associative law says that we can add or subtract in any order as long as we keep the sign. So for example, you can see here that I have x minus y is equal to negative y plus x. That is correct, right? Because notice that even though I rearrange the numbers, it is still the same question. That is kind of like saying 10 minus 5 is equal to, I could switch, I could put the minus 5 on this side, and I could have this plus 10 on this side. So the associative law allows me to rearrange the numbers as long as I keep the sign. So these two are actually the same question. In this question, the 5 is a subtraction, and in this question, the 5 is still a subtraction. This is why I just kind of get a little peeved, especially after we do arithmetic and BODMAS and we do all of them questions and things. I just get a little peeved when you see something like minus 3 plus 4 and you don't recognize immediately that is the same as 4 minus 3. Yeah? So this is the importance of the associative law, being able to rearrange things. Not only being able to rearrange things, but to be able to add and subtract things in any order. So if we look at number 2, I have a polynomial here. A polynomial is an expression or an equation that has more than one unknown. So you can see this polynomial has x and y. And you know I can't add x and y, but I could add the x's to the x's. So the associative law allows me to do that. I could say 3x minus 2x. Well, that is 1x. So that is just x. And now I could say minus 2y plus y. So that is minus 2 plus 1. Well, when the signs are different, you find the difference, which is 1y, and you keep the sign of the larger number, is minus y. Yeah, so minus 2y plus y is minus y. And this, what we just did, was we simplified an expression. Yeah, we were given an expression. It didn't have anything on the other side of the equal sign, so it wasn't an equation. It was an expression. It was a polynomial expression, and we simplified it. Yeah? And in this sense, take a look at this. What do you think this is going to end up being? Number 3. Minus 5 plus x, number 3. If you look at it carefully, that is not an adder. That's 3 multiplied by negative 2x divided by... Yeah, I know. Like you get confused by calling me Miss 2. You was really confused there. That is alright. That is small thing. That has happened to me all the time. I sure everybody's done that to a teacher. Number 3. Nobody ever hit me with number 3?
Negative 2x.
You sure? How do you think about number 3? Well, remember a couple of things, right? Multiplication glues numbers together, but so does division. Yeah? So you could see, or you could think of these two as being glued together, but then you have this divide which gives you the fraction. So you could think about this as 3 multiplied by negative 2x divided by 3. And when we do fractions, you could see that this 3 could cancel with this 3. Right? And the answer here will be negative 2x. Now be careful here. This 3 could have canceled with this 3 only because this was a multiply. Remember when we did fractions? And if you weren't here when we did fractions, we will be doing algebra fractions very soon, fractions in algebra, and we will go over all of the fraction stuff when we do that. Right? But be careful, because a lot of people will see something like 3 plus minus 2x all on 3, and you need to recognize that you actually cannot cancel the 3's here. Yeah, because of your rules of fractions, you cannot cancel the 3's here. This here is a multiply, right? So, for example, if I have 3 multiplied by negative 2x all over 3, this could be the same as 3 over 3 multiplied by negative 2x over 1. You will get the same answer because the numerators have to multiply and the denominators have to multiply, and you'll end up get this. But with an addition, you have two things being added over the same denominator. So that would actually be 3 over 3 plus minus 2x over 3. Yeah? When you add things, when you are adding two things that are over the same denominator, you keep your denominator and add your numerators. So I just wanted to make a note of this. We're not doing fractions now though. So when we do fractions, maybe in a couple of classes we'll be doing, maybe by next Tuesday we'll be doing fractions. When we do fractions, we will talk a lot more about this, right? But why could the trees cancel here? Because this is why. You could see that this tree could cancel into this tree and they're gonna have nothing left. You'll just end up with 2x. Anybody have any questions? I know I was talking a lot there, and I know all your brain probably starting to explode now. Don't worry, I promise we're almost done. All right, simplify the following. Is this the last of it? Yeah, this. Yeah, sorry. No, probably. So all we have to end the class is we just have a couple of questions, and we'll just end the class there. But before we end the class, let me get some donuts. Zara, how are you doing so far? You okay?
Yes.
Are you understanding everything?
Yes.
Are you getting any nosebleeds yet?
A little bit.
A little bit. The brain now starting to swell? Don't worry, the class done there. We just have a couple of questions just to exercise the associative law with polynomials, right? So just a couple of questions. Anybody still writing here? Right, so simplify the following expressions. We have a polynomial. We have two polynomials. And of course, we could use the associative law. So it's 4 questions. These are 2, and then we have these 2 that involve multiplication as well. But let's just do these 2 first. I'll give you guys 2 minutes and just say done it when you're done it. So I will just do them quickly because I know I don't want anybody starting to bleed through the iron thing too, right? So even though I do give very gory analogies there. So 3x minus 2y plus z minus 3y minus 4x. Thank God for the associative law, yes? Thank God. So I could see that I have a 3x here and I have a minus 4x here. We can add and subtract in any order as long as we keep the sign. So I had to keep this minus 4. I can't just deal with the 4 alone. So 3 minus 4 is minus 1. So I have minus x, right? So 3 minus 4 is minus 1. Let me deal with the y's now. I have minus 2y minus 3y. When the signs are the same, you keep the sign and add the numbers. So that is minus 5y. And then I have z minus 2z. Well, 1 minus 2 is minus 1 minus z. And this is as simple as we could simplify this polynomial. Anybody get through with it?
Yes, sir.
Yes, sir.
Yes, sir.
Janasha, you get through with it?
Yes, sir.
Ade, you get through with it?
Yes, sir.
Denicia, you get through with it? Zara, how you feel about it?
I was getting through with it.
That's alright. Let me ask you a question. Do you understand what I did?
Yeah, I understand. You like combining the two.
Do you want me to explain it one more time?
Can you explain the second one? I should be good.
All right, but I'll just explain this one the one more time, and you could see how a lot of you guys, your problems come from directed numbers. So directed numbers. So when I look at it again, this is a positive 3x, and this is a minus 4x. So in my working column, that is a positive 3 minus 4, right? So 3 minus 4, when the signs are different, you find the difference and you keep the sign of the larger number. Yeah. So 3x minus 4x is minus 1x. Then I have negative 2y minus 3y. So that is negative 2 minus 3 is negative 5. When the signs are the same, you add them and you keep the sign, negative 5y. And then you have 1z minus 2z. So that is 1 minus 2. Well, the answer will be negative 1. Negative 1z. Zara, would you say that directed numbers is the problem that keeping you back here?
Yeah.
Yes, yes. It is. It usually is. This is why I just always say, you know, all of the problems that Form 5s and things be having in maths, this literally come from SCA and Form 1. Yeah. It's quite natural, Zara. Don't worry. You and everybody else in this class, right? Trust me, no matter how smart you are, it's the directed numbers that might get you. That and careless mistakes. Yeah. If we look at this one here, I have minus 4x minus 2x. Well, the signs are the same, so I have to add the 4 and 2 is 6x. When the signs are the same, you add and you keep the sign. So minus 4x minus 2x is minus 6x. You see how those rules that I taught you in the very first class for basic arithmetic coming back for you now. Yeah? Very first class in June. Those rules that I taught you, right? They're coming back for you now. We have plus 3y minus 3y. Well, that will go to 0. So there are no y's here. And all I have left is 2z. So I'll have minus 6x plus 2z. I don't need to put any y's because there are 0 y's. Yeah. You could leave the question like this. This is correct. But if I am a good mathematician and I have manners, I will actually put it the other way around. The plus 2z first and minus 6x after. This is just me having manners as a mathematician. Right? Any questions for this? Right, so I just have 2 more. This one here is a combination of multiplication with addition and subtraction and division. So you have multiplication, division, addition, and subtraction all in one. Remember your BODMAS. Your BODMAS will help you here. 2 minutes and then I go do it. Don't worry, I go call no names, but please actually do it yourself. Feel free to get it wrong. It'll help. Right? 2 minutes. Anybody else didn't done it yet? All right, so let me just do this and get out of here. Anybody want to give me what I got for number 3? Nobody? Nobody brave enough?
So I guess 12y minus 2x.
12y minus 2x. Anybody got anything else? What about number 4? Anybody want to give me number 4? Be brave now. Get it wrong. There's no scene.
xy minus 2z.
Minus 2z. All right, let's see. Let's see. Remember what others be brain like a donkey all the time. By the way, Sibira, is that some dread jazz music you have playing in the background?
Yes, it's a third housing program.
So you've been listening to jazz while. That's interesting. Did you know I'm a jazz musician? And that's why I just have that boring elevator music in the beginning of every class. Excellent job, Sibira. Great. Right? Right. Remember, just be brain like a donkey all the time. Multiplication glues numbers together. Remember that. Multiplication and division, they glue numbers together. So this is one number. This is one number. This is one number. Multiplication and division glues numbers together. Addition and subtraction separates numbers. So you can see that is three numbers being added here. Right? The first number, 3 times negative 2x, 3 2s are negative 6x. Plus, the second number is 4 3s are 12y. Plus, the third number is, well, we could see here that, we could see that this is 4 times 2x. All of this could be divided by the 2. And of course, this 2 could go into the 2. Right? So we'll have 4 times x. This will give us 4x. Or if you want, you can have the 2 going into the 4, and you'll end up get 2 times 2x, which will give you 4x. Whichever way you cancel it, you'll end up get 4x. So now we have minus 6x plus 4x. When the signs are different, you find the difference, which is 2x, and you keep the sign of the larger number, minus. And then we have the 12y. So it's 12y minus 2x is the final answer. And let's just check number 4. So we have here, this is one number multiplied, added to this number. So this is one number subtracted by this number. Right? Subtractions and additions separate numbers, right? Added by this is one number multiplied, right? So multiplication glues numbers together. So we have negative 3x multiplied by 2y. That's 3 2s are, that is negative 6, and x times y is xy. So that is negative 6xy plus 4xy. Well, look at that. They are the same. So that means that I could add and subtract them because they are the same. Minus 3z plus x times y is xy. So look, I have our next xy here. And then I have a plus z on this side. So let me deal with the xy's first. Right? I have plus 4xy plus 1xy. So that gives me a 5xy. So that is plus 5xy. I have minus 6xy plus 5xy. That gives me minus xy, minus 1xy. Right, so minus 6 plus 5 is minus 1xy. And now I have the z's to deal with. Minus 3z plus 1z is minus 2z. Yeah, minus 3 plus 1 is minus 2. So minus xy minus 2z. Sarah, I told you that you was real comfortable acing everything in the junior class, but Sibira here will definitely give you a competition in the senior class, right? So excellent job from the both of you all. Anybody have any questions on polynomials and the use of the associative law? Zara, how you feel about these questions? Any of them correct? You get them wrong? Feel free to say if you get them wrong.
I get some wrong. I get the first two correct.
Did you understand what you did here? And here? What you did wrong? You understand the corrections?
Yes.
That is all that's important. Yeah, that's all that's important, especially since you were not with me from the beginning. So you don't know those cliches that others always be saying. Multiplication, does glue numbers together, and them kind of things, right? I'm sure you I don't know if you ever thought of it that way. Did you ever think of it that way before? Sarah? Zara, is you are talking to you?
Wait, my bad. I thought you was talking generally.
Yeah, no. But that's all right. Did you ever think of it that way before? That multiplication?
Not really, but that's understandable.
Right. Now, I will give you guys, no homework today, but I will give you guys a couple of more polynomial questions just to start the next class. So today's class, we did two things. We did transposition and we did polynomials, right? In the next class, we'll we'll start off with a couple of polynomial questions. And I think what we'll be doing in the next class, boy, let me see. I have it written here. Right, class number 3, we'll be doing the distributive law and we'll be doing factorizing, and we'll also see if we could do subject of the formula one time. I think I might be able to do all of that in one class. So don't miss the next class, because the next class we'll be doing 3 things, if we could manage them: the distributive law, factorizing, and subject of the formula. Those are some very important topics, so try not to miss it, right? Anyways, that's it for today. I think Janasha and Amir, I'd like to talk to you guys before everybody, before you go, but everybody else could get out of here, and I'll see you all on Saturday at 3, right? Take it easy. Okay, have a good night. Take it easy. So, Janasha, you missed a few classes here. And JQ, Joseph, Naima, all you get out. This is not all your business. Asiya as well. Asiya, unless you have any questions. Asiya, I hope everything is alright. Alright. Okay. So, Janasha, the last, actually, I need to stop recording this class. Let me just